We are solving exponential equations. This is the first level. Okay, so we're trying to get x by itself. So we want to solve for x and then make sure you round to the nearest hundredth. All right, so first thing, let's go ahead and get it by itself. So I'm going to divide both sides by 14. And just want to make sure I have a calculator right here next to me. 98 divided by 14 is 7. Okay. So I'll go ahead and do my work up here. So I got 2 to the x over 3 equals 7. All right. Not so sure. Let's go ahead and write it as a log then. So logarithm, log base 2 equals the exponent. The exponent's x over 3. Fill in the next spot. All right. So it looks like we need to do a change of base formula. So change of base, change of base for a logarithm. So we're changing it. We want base 10. Base 10. All right. So notice it's base 2 right now. So you may have to look it up, but the change of base formula basically means that you're just breaking this into a different log. This one's on top, this one's on the bottom. So I'm going to make it log base 10. I could make it log base e, or natural log, but it has to be something that my calculator has, over log base 10 of 2. All right, so that's the change of base formula on the left. I still got x over 3 on the right. Multiply by 3 to cancel, multiply by 3, and it would go to the top. All right? Or you can look at it as the whole thing, but it just multiplies to the top here. So this is what I'm typing in on my calculator. X is equal to 3 log 7 over log 2. All right. I get... so this is how I would do it on my calculator. Is I'm going to go ahead and do this first, because remember, you can never round in your math. So I have to keep this in my calculator. So I'm going to do, where's the log key? Log base 10 of 7 equals 8.4509 divided by log of 2, enters. And so right now, this is exactly equal to 3 times 2.807 ... Remember, you need to be able to get that stuff on your calculator too, if you're following along with me. And I say times 3. So final answer is 8.4220 ... Nearest hundredth. So here's tenths. Hundredths is this one. I looked right there. So this is approximately equal to 8.42. All right. So we got a new tool here, change of base. That's what I needed to get through it. 8.42. Got it. What'd they do? So solve log. Oh, okay. They did log of both sides. That's a good trick. I'll use that next time. That's easier, so we don't have to use change of base. All right. That's how you got the log 10 involved. Notice log 10 also. Exponent moves out front, and then get the x by itself. All right, good. Notice they have exactly what I did. They should have an infinite decimal there, but that's fine. 8.42. Got it. All right. Let's see. What are the problem types here so we get something different? this looks like the hardest kind. And okay, yeah, we'll just go ahead and do this one then. All right, so I'm going to go ahead and do their trick, which is fine. So let's go ahead and hide type so I don't have that floating in front of me. All right, so of course, first thing we want to do is get our base by itself. So divide by 75, divide by 75. 300 divided by 75. 4. All right. So now I get 10 to the 2x equals 4. All right. So I'm going to use their trick. What you do to one side, you do to the other side. So I'm going to do the log of both sides. Log base 10 of both sides. That's going to help me because I have a 10 already. But I don't even care about that. I'm doing log base 10 because my calculator can deal with it. So whether it's simplified or not, at least my calculator can work it out. Exponents always move out front. That gives me 2x times log of 10, base 10, equals log of 4. This I'm going to go ahead and just calculate. That's 1. Base 10 of 10 turns into 1. So all that goes to 1. So I have 2x equals log of 4. Divide by 2, divide by 2. And there's, on the calculator, log of 4. Now be careful, like I said, you have to do these in stages. So I'm doing log of 4, enter. I get that answer, which is 0.602 dot, dot, dot. Then I divide that by 2 on my calculator. Divided by 2. All this is equal to 0.30102 dot, dot, dot. And we want nearest hundredth. Here's 10th. 100th is right here. I look at that, drop it. So all of this approximates into 0.3 is my final answer. All right, so it's just a matter of kind of using which method you feel more comfortable with. I like the change of base. They like doing log of both sides. Either one works. Okay. And now they're doing it like or I'm doing it like them. Okay, good.